Hi, I'm David. Welcome to Tramex Talks. Good morning, Steve, and welcome to Tramex Talks.
Good morning, David. Nice to be
Thanks
here.
for
Thank
joining
you for
us.
asking.
Could you tell us a little bit about your background, Steve?
Sure. Yeah, David. I've been in the flooring industry, commercial primarily, industry for excess of 4 decades, and have been testing concrete and wood products for moisture as part of my activity, dating back to the 70s, I guess, and early 80s. So I'm familiar with, obviously, Tramex meters. I'm very, very familiar with them. I've done some testing for your factory, as you know, and I like the meters and feel relatively comfortable with those meters.
Great. The one meter that I wanted to talk to you about today is our ME5 moisture meter. And I know this is one that you use pretty regularly.
Yes.
Could you tell us a little bit about how you use this in the work that you do?
Yeah, the ME5 works quite well as a comparative meter. In other words, I can find a wet spot in a tile, floor, or wall. I can find different wood moisture contents. It's especially helpful, David, when we're doing a non-destructive floor failure. Okay, when a floor fails, we automatically look to the reason why, of which moisture is a huge contributor to failures of existing floors. So that is where the ME5 comes in most of the time. It has other features, of course, but the hunt for the culprit of moisture is what we are after primarily on a daily basis.
So the meter has the wood setting, it has a shallow depth setting, and then it has drywall, roofing setting, plaster tile, and masonry. So generally, if you're going into, say, a failure on a LVT, maybe you could give us an idea how you would use the meter.
Now let's go from the wood setting on down to the shallow depth. Somewhere a little less than a half an inch, give or take, and the give or take is based on the density of the product you're testing. So at that shallow depth, I can actually test through that vinyl product or that laminate product, and I can start looking at, inclusive of that product, the moisture directly beneath that product. That can tell me if there's any moisture in the case of concrete or wood. It can tell me that there is reason to believe that there's cause for a warpage problem or a lippage problem. Neither will it tell me if there's an air gap under that floor. I have to be sure and compress that floor. It won't read air. It's not going to read relative humidity.
Yeah, that's an important point.
It is very, very important. I see that mistake made often. People go, well, I'm not getting a reading. And that's because they're trying to read air. The meter is not capable of reading the relative humidity. There's different meters for that.
So you mentioned about using it to do a comparative reading. So can you describe how that works? If you're going into a site like this where there's a failure, you told us you're going to set it on shallow depth on the LVT, and how do you understand the numbers?
Every meter requires a user that's familiar with that meter, regardless of who makes it, regardless of which meter it is. You've got to understand what your meter is telling you. So if I was to do a comparison, I would want to know what I think is dry. In other words, if there was an area that doesn't have any problems and the temperature is the ambient relative humidity and temperature gives me a dew point, and my surface temperature tells me I'm not approaching dew point. So I've got a dry surface and I've got a non-failing product. then I can test with the ME5. On shallow depth, I like shallow depth a great deal because I don't want to go too deep into the subfloor. Got it? The structure underneath the finished floor.
Right.
So if I test an area that I really, really like and know is dry, that gives me a good reading. And let's say, for the sake of conversation, that reading was a 20 on a scale, and we're looking at the comparative scale, the 0 to 100 comparative scale on the bottom of the wood scale. If it was a 20 in that dry area, and I move around and I'm finding 15, 18, 20, 22, and so on and so on, and all of a sudden I spike to 50, then I know I've got a more than just a suspect of wet. I've got wet. And knowing that it's not inside, probably inside that product, depending on the product, obviously. Most of the vinyl products don't hold moisture within them. Wood polymer products, the ones that have a wooden polymer core, those do actually have a density factor, and they do hold some moisture. Stone polymer, a little less, more dense.
With this comparative scale, you were saying, imagine you're starting at 20. How much of a difference is a cause for concern? I mean, is it a cause for concern if I get to 30? Is it a cause for concern if I get to 40? What is that? What's gonna spike concern for you if you're starting with a 20 as your dry number?
If I'm on a 0-100 scale, it's a relative scale. Remember, 0-100, 0-200,
Correct.
0-300. So you kind of look at it that way. Remember that before we even consider the meter's answer to our question, we have to make sure that we're not testing an area that is wet by another reason.
Mm-hmm.
Back to your dew point situation, David, that you talk about so often, where we're comparing the relative humidity, the ambient relative humidity and temperature, and the surface temperature, and make sure the surface temperature is not near dew point.
Yeah, that's a good point. And when you were talking earlier, you brought in ambient, and I think that's important for people to understand is you always should have an understanding of ambient conditions when you go into a job site.
Absolutely.
For moisture testing.
Absolutely. If you do not have a thermohygrometer that tells you the relative humidity and the temperature of the air in the environment that you're testing, you're wasting your time testing. Because when you take that, I'll go into that in just a second if you don't mind. You'll take the ambient relative humidity and the ambient temperature, and the meter, your meter with your thermohygrometer will give you a dew point number. That's the temperature.
X5, correct.
You will take your infrared thermometer and you will measure the surface temperature of the product you are inspecting.
So do you do that if just 1 second, Steve, if you're in a situation where the product is still on the floor, do you take a surface temperature of the product itself?
Absolutely.
Okay.
Absolutely. You know, oddly enough, you could take the temperature of another product, but why? You're inspecting that floor, take a temperature of the floor. And you're going to want to make sure that temperature is up around 9 or 10 to 15 degrees Fahrenheit above the dew point number that you've read off your meter.
Okay, and that's just to avoid dew point issues or condensation.
That's exactly to avoid the
out.
Floor from being impacted by relative humidity transferring from the air to the floor surface. That will tweak your meter. Okay?
Gotcha.
So once you've established that it's not there, that the dew point issue is out of play, and there's no failure on the floor, you can feel pretty secure that that is a benchmark for you to test.
So if you're getting a high reading on the meter, first thing to check is to make sure it's not dew point. Is the converse of what you're saying.
Absolutely. I walk in and check dew point regardless. I check dew point on every site I visit.
Yeah, no, I've been with you on sites, and it seems to me that that's your first thing you check is ambient conditions.
Yeah, I mean, you set it up, you simply turn it on and set it up. Have a good day. In your case, I think you actually have an infrared thermometer that has a thermohygrometer on it.
Yeah, we have a few different ways that you can monitor ambient conditions. The other way that a lot of guys like to do is using a feedback data logger, where you can just set it in a room and start looking on your app and actually recording and monitoring the ambient conditions.
Yeah, I do that as well, as you know. And
so the other benefit, Steve, is with the data logger, when it transfers into the app, you get a pretty cool representation of the ambient conditions through a psychrometric chart.
Absolutely.
You ever use that?
Yeah, it's really cool. And then I take a screenshot of it. It comes off the app, off of your Tramex app. And I put that as part of my report. Obviously, then you follow through with a proof that the surface temperature is not nearing or approaching or heading toward dew point. And you've succeeded. Oddly enough, most of the inspections are not dew point issues on the what we call used or the installed flooring. Most of the dew points we see, David, dew point issues we see are on new constructions.
Yes.
You know, even on the residential installations, if people were to test dew point before they installed any product, they would save themselves a huge expense in failures. Just check the dew point. If it's got a high dew point, you have to see why. Make sure your ambient conditions are within the tolerances. We want the ambient temperatures to run between 65 and 85 degrees Fahrenheit. We want the relative humidity to stay, hopefully, 35 to 55. Now, given the fact that Arizona is going to be lower possibly, and Florida is going to be higher, but somewhere in that range of 35 to 55 relative humidity, that'll give you a decent dew point number.
And then again, at time of install, you're just making sure that the temperature of the concrete surface is at least 10 degrees above that ambient dew point.
Yeah. And wood as well. Wood subfloors, OS-oriented strand board, plywood, concrete, gypsum, all of them require an absence of the humidity being placed on or in that subfloor. Okay, it's not limited just to concrete.
And the understanding is because all of those subfloors that you mentioned will absorb moisture from the air if there is a dew point issue.
Absolutely.
With the ME5, we were talking about the comparative scale, and then you mentioned that you like to use the shallow depth feature, which is going a little less than a half inch deep, and will look through a material basically. Do you ever use the wood scale?
Sure.
So the first setting is wood timber. You could talk about how you use that in your daily work.
On extremely large wood jobs, it's incredible for solid wood, because you're understanding that the setting, the wood scale setting is a national setting. It's like 0.4 or 0.45, whatever the setting actually is, a specific gravity. If you were to test a board with a destructive, invasive is the better word. If you were to test a solid board or a thick veneer board with a pin meter, invasive pin meter, and were to arrive at that calibrated, equilibrated moisture content, the moisture content of that wood, when it's reached equilibrium with the ambient conditions, you will arrive at a number. Let's say that you were testing the wood and you put the pin meters in and you found 8%, 9% of moisture content. You go to the wood setting on the ME5, and I have found that it gives me that same number. Once it does that, you can establish that you don't have to go poking holes in the wood till the wood acclimates to the conditions of use.
Interesting.
You can
Yeah,
use
so it is important to note that the number you're going to see on the meter might change depending on the setting for the wood. So there are different wood settings, and within the ME5 user guide, you can see the conversions if you're using a wood with a different specific gravity.
Correct. And it's not a great deal, by the way. A difference between Scots pine or Douglas fir and hickory may be 0.75% or 1%, depending on the relative humidity and the conditions that is being used.
I see. So what you're talking about is a situation where you're doing an install, the product arrives to the job, and now you want to make sure that the wood is acclimated, and you're checking the moisture in all of the product. So what you said is you're going to start first with something like our CME5 with a pin probe connected to it, take a reading and get a percentage of moisture content for that wood, and then you're going to compare it to a reading with the ME5 on the wood scale.
Correct.
And you're saying, excellent. So then the benefit of this is it's just going to speed up your process.
Oh, yeah. You can
checking your pallets of wood.
Sure. Yeah. That's the whole point. The funny thing about pin meters is the pin meter is an instant read for sure, but they fluctuate sometimes, especially those that have cables attached to them, regardless of the brand, by the way.
Right.
Regardless of the manufacturer, that cable creates a static and you have to reset. So you don't want to go that, not to mention the fact that you don't want to go poking holes in the entire
in every piece of.
Yeah. Because it takes you quite a long time to do that. But the ME5 speeds that process up once you go back to understanding what the benchmark is that you're shooting for.
For sure. So can you describe a little bit the difference between, this is a dual depth meter. So again, it has a shallow depth, and then the other settings are going deeper than the shallow depth, generally up to 1.25 inches is what we say.
Yeah.
Can you describe how
right. I'm sorry, go ahead.
From your experience, you feel like it is about 1.25 inches?
Yeah, and again, very difficult to gauge that. Remember that these signals that are being transferred are reading the entire length, the entire depth, not just portions of it. They're not just reading here. They're not just reading here. They're reading all of it. And that's where you change the depths. In other words, you can read it on shallow depth, and then you can read it on the deeper. So now you're reading less than 1/2 inch. Now you're reading around 1.25 inches. You're going to see the difference. You're going to see a marked difference in that equation, that moisture equation.
And if say you're on a product like LVT, there's a failure, you're out doing your survey. Are you sticking strictly to the shallow depth setting when you're investigating that, or do you also go to a deeper setting and compare that way?
Yeah, you can do them both, but I care more about the surface moisture of the subfloor in that particular case. Now let's go to a ceramic or porcelain or stone.
So a tile.
Yeah, I like to look at a deeper depth on that. I need to know, and I do compare them. I compare the top of that setting material, if you will, the setting material portion of it, because it's a cementitious product, to what's actually underneath it. You got it?
Yeah.
Yeah, that's what I like the comparison between the shallow depth and the secondary, the deeper depth when I'm doing a hard surface product.
Yeah, the benefit, I guess, anytime you can compare, you can quantify. So the same concept you're using that you described earlier with the shallow depth, where you're finding a known dry spot and then you're comparing
Yeah, that's the
that
whole
way.
point. That's where the world of quantification and qualification seem to trouble some people. You're actually qualifying with reasonable knowledge within a very, very small window of anomaly, if you will, or good reading. And once you get the good reading, you've qualified or qualified to quantify or quantified to qualify. You get actual numbers, and those numbers
Right.
do mean something.
Correct. So that, and like you said earlier, it's about getting to know your meter and understanding the numbers. I think the important thing when people need to understand, when it's on the comparative scale that you're using, or when you're doing comparative moisture testing with this meter, it's not like looking at your watch and that's what time it is. So you do need another number to compare it to, like you pointed out earlier.
I do. That's exactly what it is. You have some more ready available numbers, if you will, gravimetric numbers on your X5. For example, is a wonderful example. I can take your concrete moisture encounter product dating back 20 years and actually grab a real number if I use it properly. And I know we're talking about the ME5 today, and I'm sure we can talk about the concrete moisture encounter line at some point.
Yeah, I mean, there is some similarity in the sense that when we look at the top scale on the ME5, it says wood percentage MC. So with concrete, we're also looking at percentage MC. So percentage moisture content.
Exactly.
So similarity is there for sure.
As long as on anybody's meter, you don't disrupt that signal. You do not disrupt that. You do not disrupt it with coatings. You do not disrupt it with air, right?
Right. I know you mentioned earlier that you use the tile setting often when you're looking for failures behind a tile, and you're so that's scanning the tile and then going back to the backer, the cementitious board behind the tile, looking at the adhesive, and so going about an inch deep.
Yeah, you're trying to you mix it with shallow depth to the product depth. And you know, the restoration people that go in after there's been a flood, a plumbing leak, they find the ME5 actually to be their favorite tool. You can set it on one of the deeper depths, the drywall depth, for example, and remembering that you're not going to read the air behind the drywall, right? The wall board. But if they take that and they arrive at a dry standard at maybe face height, and they move down that wall board and they find that the bottom 1 foot of it pegs the meter or jumps quite high on the meter, that's proof positive that they've had a flood. Now, furthermore, these are non-invasive, because they're invasive tests that people do all the time on that. But where do you test for that? Where do you do an invasive test? Well, you do an invasive test by using this particular meter and finding the difference in wet and dry. Why are you going to go banging holes in a wall board if it's not wet behind it, right?
And then some people will do will look at RH within the wall. So, you know, how to understand that difference if you're looking at RH as opposed to this is the ME5 is giving a percentage of moisture content number.
Yeah, the ME5 is reading moisture, liquid, solid moisture, not air. So it's not a thermal hygrometer. It's actually reading a moisture
reading the liquid
content.
moisture as instead of vapor.
Correct, liquid. Yeah. When you're reading relative humidity, you can read relative humidity, and it's going to give you a representative higher number where there's higher moisture, yeah, that's fine. But you really want to know where it's wet as opposed to dry. We deal wet and dry, wet and dry.
Right.
Again, restoration people want to know it's dry when it's dry.
Right.
And that's why the ME5 is there, is in my experience that I've seen, the restoration folks are trying to dry what's been wet before, and they like the ME5 for that reason. They go in, they go, oh, I know this is wet. And then they come back and they continue to dry and dry and dry, whether they put manifold systems in the walls and floors or whether they use fans to dry the wetness out of the product, whether it's, again, wallboard or wood. Usually they'll find these problems at the junction between the vertical, the wall, and the floor. In this case, most cases, concrete slabs or wood subfloors.
Right. And I guess the important thing in that field is understanding the different materials that you're dealing with and what is dry. Again,
absolutely.
Like in the case of concrete, it always holds moisture. So some things hold moisture, some things get completely dry, as say opposed to like a gypcrete will dry out completely, as where concrete will hold moisture. So I'm sure that's important when you're looking at different materials and these different settings on this meter.
Yeah, every product has a point of saturation. In other words, gypsum, to your point, can almost completely dry out. In other words, it doesn't really hold moisture. It will evaporate moisture. It can pass through quite a bit faster than a more dense product. So let's say, for the sake of conversation, that the gypsum screed has a moisture content at dry of less than 1%. Your concrete slabs, we'll say, will have a moisture content of less than 7%. Quite a bit less than 7, but 7 is about max on concrete, unless it's being impacted by a water source somewhere.
So 7 on concrete is saturation.
Yeah, that's where we're trying to go with that, David, is gypsum is going to evaporate any water to a greater extent, for example, than concrete. Now moving on into wood. So we got gypsum, we got concrete, and then we go to wood. Wood can actually, after it's been dried and put in place, can actually gain up to 25 to 30% of moisture. You see the difference? So the products,
big difference.
Yeah, there's a huge difference. So you got to know your product. What product are you testing? What is it really made of?
I guess that's part of the concern when people are using this meter, say, like you mentioned, in a case where there's a failure with LVT or laminate floor or different floorings like that. We're again recommending to use the shallow depth setting, so people aren't confused by the other settings of plaster tile, masonry, drywall, etc.
I think you're correct. That's from the perspective of a field technician. It's critical that you understand that the products are going to be a different equilibrium moisture content. But yeah, David, that's, if there's any point that you can drive home, is that know what you are testing and understand what your meter is telling you. Again, I think the point we just made about that gypsum versus concrete versus wood is superb.
Right. And again, with these different materials, it's about knowing your setting as well. So like we were talking about gypsum and concrete, when we're using our concrete meter, especially the X5, to get that 1% number or less that you're talking about, is using the CM anhydrite setting on the CME X5.
Correct.
Which is giving you that scale of that you're talking about, where 1% is generally considered 1% or less, or sometimes it's even, I've seen it as 0.5% or less is considered your dry zone.
That's interesting. We're bouncing back and forth from different materials, but I think that you can probably do a couple of Tramex talks out of some of that, mix them up.
For sure. Yeah.
There's been confusion in the field over many, many years by people saying that plywood and oriented strand board and wafer boards don't have a specific gravity. That's just not true.
Right.
Those specific gravities are running a little more than a softwood, a little more than a pine, and a little less than a hickory probably. But I think each manufacturer, if you were to pick up the phone and call Louisiana Pacific or Georgia Pacific or Huber that make these products, they're going to tell you that that the products have a dry, wet number.
Right.
And it's pretty normal. The OSB and plywoods that I've experienced come out of the factory somewhere between 8 and 14%, I believe is the number. It's a recollection number 8.
And again, the specific gravity is looking at density of a product, and the importance of that in our case is knowing that the setting on the meter is giving us an actual quantitative number. So by adjusting, so with the ME5, by knowing the specific gravity, we can make an adjustment to that scale and get a quantitative number.
Exactly. And if it's not on the zillion species that you have in that meter, you can pick up the phone and call the factory that
right,
makes
exactly.
that, and ask them what it is. And then you can find one that's comparable to that.
Right. With that known specific gravity, you can make the mathematic adjustment.
Absolutely. All day long.
Yeah. But the important part is that the most effective setting you find for installed flooring, looking for source of moisture problems, is the shallow depth.
Oh, absolutely. Absolutely. And the wood used for pre-install conditions, that's vital. The drywall, that for restoration people, and the wood settings. I mean, that's what it's about. The meter is a daily used. You use it every day. If you don't carry it with you, you're crazy.
And that just is a result of the versatility of this meter and really understanding how it's working and can be used to the benefit of finding moisture in a variety of situations.
Absolutely. Yeah, absolutely. The meter, I carry, as you know, a data logger and an X5 and an ME5 and a lot of other tools with me, sometimes not knowing what I'm going to get into. The ME5 is used literally on every job of an installed job, every job.
Steve, it was great talking to you, and we really appreciate you sharing your knowledge with us. There's nothing like real life field experience to let us know how these meters are working in the real life situation.
David, I appreciate you reaching out, and to me, of course, thank you for that. But putting this information out to the public is critical. I'll tell you what, let's do it again someday.
Yeah, I think there's a lot more knowledge that we can try to extract from you and share with everybody.
All right, David, take care. Nice seeing you.
Thanks so much. Thanks for joining us on Tramex Talks.
Thanks for joining us. We'll see you next time.